Hello, I'm Kokchen Jinkus. Now here is our simulation projects. Now you can see this. This is my simulation project. This is a huge website. So no further ado. Now we start. Here we talk about history first. Here's the normal class, classical class. A lot of text, a lot of photos. Even the best class, I think, is for photos, algorithms, and mathematics. No, we are not talking about all of those. Work by work, because it is classical. We are doing simulation. So Dijkstra, A star, we do it on simulation. No bullshit. Now you can see even the best website, best teaching materials. They are full of photos, fixed data, or maybe some animations. It is not good enough. It is not yet a simulation. Wow, a little bit lack the website. Poor computer, but it is okay. So what is this simulation? This is the path algorithm simulation. Okay, we start and we calculate it. Oh, it is a normal way to see the path algorithm, right? How about different? How about different ways? Then this is only one way. It is just like brute force or something. What is the other algorithms? So here we have different algorithm to give you to child about to taste good insight from the dragon to the goat we built here. And here we going to look at it, how it calculated, and different ways how we find it. This is, and also we have the this function can put and unput block to let people to simulate a better way to understand the path. And here is A star. This is Dijkstra, and he's greasy and different things. And because this is a huge website, so we strike onto the seven. So we demonstrate it like this. This is a huge website. So we can let them play with the sandbox. This is the way to let them play with it by themselves to see how the algorithms works. For example, A star, and we can read the text about what makes it is A star algorithms and all those Dijkstra, also different algorithm. We can see their codex and understand what it means. We talk about this A star as an example. So here, look at it. A star is based on the G. Oh, never mind. He just calculated, and it stopped because he hit the wall and tell you different things. A star is actually based on the distance, distance values and these values, and then calculated. A star is a more better, not a better, but a combined rate of Dijkstra algorithm and greedy algorithms. We can show it to you. We clean all those, not randomized. Maybe just like that. Like greedy algorithm, it one strike onto the path to the goal, because what he uses is the destinations and then calculated the distance. And Dijkstra is a different way. He doesn't know where is the end, so he need to brute forces like a droplet and try it every way. This is a different algorithm in different situations. In such as this case, it is very poor. But greedy algorithms also have disadvantages, because greedy algorithm is calculated the closest path from this to this. So by letting the students play with the simulation, they can know that greedy algorithms maybe sometimes too optimistic, and then finding a wrong path. Just like maybe this can calculate it, and then also this can have all the full animation. So because the greedy algorithms like here, it is straightforward to the goal here, and then if it is wrong, it is all blockade. It is very bad for the greedy algorithms, and it goes the wrong place. And then you can see they try all the way, and then it cannot find it. It cannot find the goal, so it is a F grade. But however, in Dijkstra algorithm, the ancient old classic, He tries it anyway. In this situation, it's also not very good, something like that. A star combine both of it. Mm. But both of it is work very bad that way. Mm. Maybe we can look at we stop the auto pause here. You can see the student can play with the different algorithms here, and then looking for them how they calculate the math here, and something like depth first. And we can talk about that. What he chose the depth more than the way he never go back. So this is her curved way to solve these problems, and also this is the biochart. It come from two sides and then meet it, knit it together in different algorithms. This random rock is a joke. It's like the monkeys. It is forever to chase the chaos. So it is different algorithms say to try, and we have a different level after they doing the sandbox. Like the first one, how to let the greedy algorithms to get stuck, and because they know the try to the sandbox about the greedy algorithms, so they can see how the greedy algorithm get checked. If they don't get it, we also have the tips. In easy mode, we can check it and then get more blocks. So this game is basically give you a set of blocks, and then you run it, you trap the greedy algorithms. But by default, the greedy algorithm runs very fast. So it is our goal is make the path more than 25. Just like that, something we tried, and then we can pass it by checking the greedy algorithm to get stuck here. And the second is called, this is the droplet. The BFS as such is basically the more worse way of the Dijkstra algorithms, and you can by doing those sandbox and then try and error, and they can learn the different methods, and then get a different things here, and then you can need to have a this game is give you 10 blocks, and then you need to get more than the waste energy to check the BFS algorithm. BFS is basically like Dijkstra. Okay, and after all of those, we have online games, and then we can check whether the student is understand or reinforce the learning. Like this Dijkstra, greedy, and A star. How did those calculated? We can play it. So they calculated here, and then it is wrong. It should not find those three. It should find those three first. So it has penalty or something, and they counted the time, and then it is online, and then it will show it on the leaderboard. Show it on the leaderboard here, and then after all of those, maybe, and then after all of those, we may have the little quiz to reinforce the learning here, and what algorithm is very optimistic, going very fast, but which of it go very fast is greedy. What may be stuck in the dead end and then retry and doesn't grow out is also greedy. And what is the algorithms to get the shortest path? It is a more harder question. It is BFS because it's tried everything. So is it like that? Yeah. Thank you.